our last week of teaching, but I doubt we shall need another lecture next week to get this finalized over syllabi. This is your last week of teaching, all right? So, but we haven't done the midterm already, so which was scheduled after midterm exam. So midterm is a midterm paper, in fact. So I didn't deliberately put it on because it was one Ramadan, second day was approaching. So I planned that because you are a large number of students, more than 50. So I cannot make 50 topics for all of you in a small syllabi. So therefore, I decided to include this midterm exam from whole of your syllabi, so that everybody should have a different topic of assignment. So I have started deciding the topics, but it shall take further a few days more. So I shall communicate all of you the topics with your roll numbers right after in this due week, inshallah. So you shall be given 2 weeks. I hope all other papers, 4 other papers, you would have already completed. This is the reason why, because you were also busy in devising the midterm paper in that due time in Ramadan. So I didn't feel it good to include this as well. So now you are free. You don't have any other assignment at the moment. So with 2 weeks time, you can easily get this managed. All right. So the whole it shall be done this week in the end of probably Thursday or Friday or maybe longer. I shall send electronically the soft copy of the topics, the PDF file. So all of you can see it yourself, and every student shall write this up. It may be a mechanism, it may be a topic which is given to you. You are supposed to define this and exemplify with a suitable examples. The more you are illustrating this, but it shouldn't be a copy paste, or it shouldn't be just you are copying from somewhere else, from a book or from any other resources. You are supposed to get through understanding, core understanding of that, and then explain this. You shall write this on that piece of paper, anyone, and then you shall take the snapshots and you shall generate a PDF file of all of these page wise, writing the page number on each. So page wise, when you devise the file, then you shall email me. I shall present the email address in the assignment, inshallah. So this is the way you shall be evaluated 15 marks midterm exam. In lieu of midterm exam, we are having a in fact midterm paper. So that shall be devised, communicated this week, inshallah. So the last type of mechanism which left during this due course is the elimination reactions. You have already come across the substitution reactions. You have already come across addition reactions. The third one included in this syllabi is elimination reactions. Other three mechanisms like redox, mean oxidation reductions, similarly, molecular rearrangement, pericyclic reaction, these are included in next semester. In fact, it is not included in this syllabi. So in fact, this reaction mechanism course is divided in two courses. One is this Chem 563 and another course which shall be reaction mechanism titled, which shall be, you shall be studying this in next semester, means semester 3, the fall 2020, inshallah. Anyhow, this is the last few lectures. Definitely I shall need one lecture next week, but maybe it extended to another week, so we shall have additional classes. This additional 2 classes is basically due to because when it was closer from 16th of March, so we didn't have a class till 25th of March. So during this 2 weeks time, we couldn't manage the classes. So due to this deficiency, we are short of a week. So probably next week we shall be having one class or maybe 2 classes. All right. So keeping in mind, although this is the last week of teaching, but we shall continue this next week, inshallah. All right. Right. So just like you have already come across what is elimination reaction. Elimination reaction and addition are totally opposite to each other. In addition, you have a unsaturation in the molecule in which something adds up, all right, and results in the formation of an olefin. But here it is opposite. In case of elimination, something leaves the molecule and results a unsaturated system. This is what we call normally a elimination reaction. So you can see here, this is a saturated molecule in which two atoms A and B are living, resulting in the formation of an olefin. But what happens opposite? If let's say we have this olefin, syn addition takes place, what this result? It always results a syn addition, and we always end with a retro entity. This is what you have already come across. In fact, this is a trans olefin. In addition, if you remember, it always results in the formation of a trio entity. You can see here these two hydrogens are like substituents are opposite to each other. So this is in fact a trio product. Trans olefin, syn addition. This is opposite in fact. But if you, this is elimination in forward direction, but in reversible direction, this is a addition in fact. Let's say this is an unsaturated system. If A bond B molecule adds to this, it always results in the formation of a saturated system. So a pi bond cleaves and two new sigma bonds are formed. In fact, this is what you have already come across in addition reactions. This is the elimination, mean opposite to addition. Addition results in the formation of a saturated system starting from a unsaturated system. Elimination starts with a saturated system and results in the formation of a unsaturated system. This is totally opposite to the elimination. So elimination and addition are totally opposite to each other in fact. But this is only one kind of elimination I have presented. Elimination is not only one kind. Let's see if two groups are living which are beta to each other. Let's say this atom A is living, and whenever this elimination takes place, one atom always leaves with electron pair, other atom leaves without electron pair. Let's say this is an atom A, means this is more electronegative than carbon. So it is leaving with electron pair. If it is leaving with electron pair, this carbon shall become electron deficient. As a result, this atom B, this leaves to satisfy the positive charge on this carbon. So we get a double bond at this position, a pi bond formation. If A is leaving with electron pair and B is leaving without electron pair, so two electrons are lost and two electrons are gained. So overall we get one pi bond. This is how the mechanistically this happen. More electronegative atom leaves with electron pair, just like you have seen a substitution reaction, but nucleophile doesn't approach it. A base is required. A very special base you shall see in the end of this course, which base is the best base. All right, so you shall come across that later, but at the moment you just focus, this is a good base, not a good nucleophile. So if you have a good base, bad nucleophile, then it shall undergo only elimination. If your base is not a good base, it has some nucleophilic character, then the substitution as well as elimination shall proceed side by side. You shall see just after few slides. This is called SADSAP, Hoffman, and you have already come across a few other consideration, Markovnikov's addition, and so many others. You shall see that in due course. Substitution and elimination go side by side, but we can control the reaction more in elimination or more in substitution. All right. So you shall see theoretically in next slides how we can control elimination, dominating, and how we can dominate the our elimination and how we can dominate substitution reactions, but they go side by side. Reason, if we don't have a good base, if we have a good base, only elimination occurs. If we have a base which have a some nucleophilic character, then we shall get substitution taking place here with Walden inversion, and there would also be a mechanism possible that it may be undergoing elimination. Both are competing with each other in fact. So do not forget, this is called beta elimination. Why beta elimination? Look at A, look at B. With respect to A, this carbon where A is attached is always called alpha carbon. This is alpha. And this other group is leaving from this carbon, which is a beta carbon to A. Now look at B. This carbon is alpha and this carbon is beta. So with respect to each, A and B are oriented at beta position to each other. So if one group is leaving with electron pair, other is leaving without electron pair, and they are beta to each other, this type of elimination is called beta elimination. All right. And beta elimination always results in the formation of an olefin. This is a very important reaction. This is one class of the elimination in which we mostly focus on, but it is not only one class. The elimination is not only beta elimination, it may be alpha elimination, it may be gamma elimination as well. Now what is alpha elimination? If two living groups, let's say here you have seen two living groups A and B. These two groups were, with respect to A, this B is at beta position. With respect to B, A is at beta position. So because both A and B are beta to each other, that's why this type of elimination shall be called beta elimination. Now what is alpha elimination? Alpha elimination is opposite, in which when two living groups, let's say this hydrogen is living without electron pair, this chlorine, which is more electronegative, is living with electron pair. All right. So what is happening in this case? Look at this. From with respect to hydrogen, this carbon is alpha. The same carbon is alpha to this chlorine, where hydrogen is attached. So these living groups, hydrogen and chlorine, both are attached to same carbon. In other words, so they are attached, they are alpha to each, and they are attached to same carbon, whereas these two atoms are attached on adjacent carbon. All right, this is another word you can define. If two living groups with electron pair and without electron pair are attached to same carbon atom, so they are at alpha position. Such type of elimination is called alpha elimination. But if two groups are beta to each other, or in other words, adjacent to each other, all right, adjacent, neighboring to each other, then they are going to result a olefin in fact. If these two living groups are gamma to each other, look at here, this hydrogen is living without electron pair, and this is living with electron pair. You see, this is alpha, beta, gamma. You see, this bond is cleaving in fact. So when this bond is cleaving, so we are getting, you see, this carbon is alpha to this carbon is, this is beta and this is gamma. So these two groups are living, which are alpha, gamma to each other. So we have less than 1 minute remaining. We shall log in again. So I'm going to close. We shall start again.